So next, we're going to look back at these graphs and tables, and we're going to talk about starting point. But I'm going to switch back to the monitor so you can see what the verbal description of the starting point or the y-intercept is, and also what it looks like or how it appears in the equation. So when we talk about y-intercept, a more generic way of referring to that could be the vertical intercept, because it's the y-axis is the vertical axis, and y isn't always our variable name. When we talk about the y-intercept or the vertical intercept in verbal situations and in word problems, for example, it's a lot of times referred to as a starting point or the starting amount. That's the amount we start with when we have 0 of something else. So it's called the y-intercept. It's called the starting amount or starting point. It can be a down payment that you pay before you start renting something. It could be a fixed amount. You have a fixed fee, a shipping and handling charge, and then you pay a per pound charge or a per day charge after that. So that's where that comes from. And students should be able to identify the starting point, the y-intercept, from verbal situations. Now also, it has a letter associated with it, and that's B. And so if we think about it, we're talking about the y-intercept. That's where our y value or our input value is 0, and wherever that hits our y-axis is going to be our B or starting amount. Because of that, it'll have the coordinates of 0, comma, something. And whatever that something is going to be your y-intercept or your starting point. Okay, so let's look also in the equation where it appears. Again, we're going to take our equation and we're going to solve it for our dependent variable, our output. And so if we have y equals mx plus b, b is our y-intercept. So if a student has an equation and they've solved it and simplified it, that constant term is the y-intercept. Because think about it, if we put 0 in place of x, then that whole piece of the expression, m times 0, is going to be 0, and all that's left is the b. It's also 0 in our proportional equations. When we have y equals kx, there is no plus a constant term, because that constant term is 0. And this is where we get the idea that proportional functions are linear functions that pass through the origin because the y-intercept is 0. Both in the graph, in the table, and in the equation, we have plus nothing or plus 0, so our b is 0. All right, so now we're going to go back to the graphs we looked at and try to identify that starting point in our tables, in our graphs.